Welcome to section 1.3, Infinite Limits, Asymptote and Piecewise Functions. So the essential question for this section is, how do we identify infinite limits, asymptote, and limits of piecewise functions? So here, you might think that we already discussed this before. For the asymptote, you'll see that the connections between the limits and the asymptote. So hopefully you will have a better understanding of our discussions from Algebra 2. Now let's take a look at the examples here. There are 6 examples for these sections, so it's going to be a little bit lengthy demonstration for today's exercise. Example number 1. Find the limit as x approaches 0, 1 over x squared. So if you think about as x equals 0, what happens? X equals 0. As it gets closer and closer to 0, it becomes, so directly substituting the numbers x with, you know that 1 divided by the very, very small number. So think about 0 is a very, very small number. What happens? 1 divided by a very, very big small number. It becomes infinite, right? It'll become an infinite. Here you can think about what's 1 divided by 0.1? That's 10. What's 1 divided by 0.01? That's 100. What's 1 divided by 0.001? That's 1,000. So that should give you a numerical examples where I'm leading. As you divide by a number that's getting smaller and smaller, you will eventually approach infinities. How about example number 2? I'm asking you to find the limit as x approaches to 3. What is the value for x over x minus 3? So again, if you use the direct substitution, what happens? 3 divided by, so 3 minus 3 is 0. So obviously, we cannot do that. So what do? Do you remember from the previous sections? What we can actually do is to find the limit as x approaches from a number smaller, so that means coming from the left-hand side of 3, what happens? So if a number smaller than 3, so this would be negative. A number smaller than 3, this would still be positive. Positive number divided by a negative number, what happens? It's going to be a negative infinity. How about if you take a look at the number coming from the right-hand side? So a number a little bit bigger than 3. A number bigger than 3, so the top part will still be positive. The lower part will be positive. A number bigger than 3. So think about this is coming from the right-hand side of 3. So that means it's going to approach positive infinities. That basically means that you will end up with different values for the as x approaches to 3. So what conclusion can we say? Since one goes to negative infinity, the other one goes to positive infinity, the limit does not exist. You cannot find a limit for these two functions values. Okay, the value function, the limit for that particular example does not exist. So this example is asking you find when the limit does not exist. And identify the asymptote. So what do you think where the function value, the limit doesn't exist? So looking at this rational expression, so first thing comes to my mind is I would like to factor out my denominator, see if there's anything I can cancel from top or bottom. So first I'm going to factor out, since every term has a factor of x, I'm going to factor that out. And then from here, you can think about what are two numbers that multiply, you will have -6, and as you add these two numbers together, you have +1. So it looks like x plus 3, they are the same factors, top and bottom, so I can reduce them. So the whole thing reduces down to, again, reduce, that means it's down to 1, okay? So that limit, that tells me that if the limit does not exist at x equal to, so do you see that when x equals 0, it'll make the denominator equal to 0. When x equal to 2, it'll make the denominator equal to 0. So these are the two locations where your the function limit does not exist. You can take a look at the previous example. Limit when x equal to 3, the function limit does not exist. So I'm basically using the concept from the previous example, and that tells me that I should have a vertical asymptote. Vertical asymptote right on x equals 0, x equal to 2. So this is the part where we talk about in algebra 2. How do I find the vertical asymptote? I set my denominator equal to 0. Okay, and then here in calculus, we call it the limit doesn't exist, because as x approaches to 0 and 2, you'll run into this kind of situations. One goes to positive infinity, the other one goes to negative infinity. Example number 4. Find the limit and horizontal asymptote. Horizontal asymptote for how do I find it? So do you remember that when it comes to horizontal asymptote, we know that it's going to be looking at the degree of your numerator compared to the degree of your denominators. So since the denominator has a higher degree than your top, then I know automatically the horizontal asymptote is going to be y equals 0. What does that mean? It means that as x approaches negative infinity, your function value is going to approach 0. As x approaches positive infinity, your function value is going to approach 0 as well. So that's the horizontal asymptote. As x gets bigger and bigger, as x gets smaller and smaller, you are going to end up, the y value is going to end up as 0. So that's how we use the horizontal asymptote. How about the second one? So we would have the function value of So again, think about horizontal asymptote. Think about the horizontal asymptote. What is the degree of your numerator to the degree of your denominators? So obviously they are second to the second power. This one is to the second power. So I know as x approaches infinity or x approaches negative infinity, you will have function. It's going to approach y equals 3/4. I'm taking the leading coefficients for top and bottom. So as x approaches positive infinity, as x approaches negative infinity, you will approach, the function is going to approach three-fourths. And we mentioned this in algebra 2 again, in algebra 2. So hopefully that bring back your memories there. So that's 4b, and then 4c. Find the limit as x approaches to positive infinity and negative infinity for this function. So this time, do you see that the top, the numerator, has a higher degree than your bottom? Numerator has a higher degree than your bottom, so it doesn't have any kind of horizontal asymptote. So maybe in your Algebra 2 class, your teacher mentioned this to you. Look at linear equation. Linear equation, you can think about y equals x over 1. So your numerator has a higher degree than your denominators, x over 1. So that then there's no horizontal asymptote for linear equation. So that should give you a good idea of how to think about the horizontal asymptote when you have a numerator that's higher degree than your bottoms. So that basically means that as x approaches to negative infinity, the function value for this one is going to be negative infinity. And then for the function as x approaches to positive infinity, so you plug it in, a positive number divided by a positive number, it's going to end up as a positive number. If you plug it in negative infinity, negative square is still positive. Positive divided by a negative number. That's why you have a negative infinities. So this next example is trying to explain what's the reason why. The why behind example 4b. Why the example 4b has a limit of 3/4. So I'm going to use a very simple concept to explain this. I'm going to divide the top and bottom with the highest degree. What's the highest degree? So obviously this is a quadratic equation. The numerator is a quadratic equation. So I am going to divide it by x to the second power. So let's go ahead and divide your top and bottom with x squared. X squared, okay? So what is 3x squared divided by x squared? 2 divided by x squared. So you have to divide every term by x squared. You have to divide by every term by x squared. You do something to the top, you have to do exactly the same thing to the bottoms. So as I divide it by the highest degree, x to the second power, so I have 3x squared divided by x squared, which turns into 3. 2 divided by, so I'll keep it like this. Same thing for my bottom, it becomes 4 minus 2 over x plus 6 over x squared. Now I'm asking you to think about when x approaches infinity, what happens? So 3 and 4 is obviously it's a constant. It's not going to be affected by x as its approach to a number. But see, if you have something at the denominator that's a very, very big number, 2 divided by a very big number, this term will eventually become 0. So the same thing, 2 divided by x, a very large number. 2 divided by a very large number, this term eventually goes to 0. 6 divided by a very large number, this term eventually turns into 0. So it's basically you have 3/4 left. And that's the reason why you have a horizontal asymptote. As x approaches to a very big number, you have a horizontal asymptote at 3/4. And the same thing can be applied to negative infinity. You can use the same concept to explain it. 3/4. And the last one is going to be a piecewise function example. So this would be the piecewise functions that I mentioned in the note at the beginning, piecewise functions. Okay, and what's the piecewise functions here? So for anything less than -1, the function is 3x plus 4. For anything between 1 and 3, it's going to be 2x plus 3. And then for anything greater than 3, it's going to be x squared minus 2. And you are asked to find the limit as x approaches to 1. Negative 1, I'm sorry, negative 1. What's the function value? And as x approaches to positive 3, what's the function value? Okay, negative 1. So do you remember, in order for you to find the limit, you will have to find the limit from the left-hand side and the limit from the right-hand side. So that's what we're going to do. We're going to plug it in negative 1 from the left-hand side. So which function should I use? Do you see that left-hand side? So I have to use this one, meaning that I'm going to plug it in 3 times negative 1 plus 4. That's for the left-hand side, which is going to be positive 1. How about the limit coming from the right-hand side of negative 1? Right-hand side of negative 1. So do you see that anything from the right-hand side, I would have to use this function. So 2 times negative 1 plus 3, which is positive 1. So they turn out to be the same number. So what conclusion can we say at here? It's going to be, because these two numbers, left hand, right hand, they end up with the same limit value. So I can say it's going to be positive 1. How about the one approaches to 3? So I'll do the same thing. As x approaches to 3 from the left-hand side. Left-hand side, so anything for the left-hand side, I will have to plug it in this one. 2 times 3 plus 3, which is 9. From the right-hand side, which is, so 3 squared minus 2, which is 7. These two numbers, so obviously they are not the same number. So the conclusion I can say for this, as x approaches to 3, because these two numbers are not the same. So the limit does not exist. The limit does not exist. And that concludes our lesson for 1.3. If you have any questions, please send me an email.